Just in previous sections, we have learned how to compute the correlations. Now, in these sections, we will see how to compute the confidence intervals. And in this lecture, in this video, we will learn what is actual confidence interval and why we need to learn this concept. And in next lecture, we will learn how to compute this confidence interval and how these things are really applicable on real data. Now let's see how these things are actually what it actually mean about confidence interval. Let's see. So already suppose if we understand these things through an example, that's better for us. Suppose let's take x is a random variable, that's the denoted the height. As regular, I have taken the same random variable x as denoted the height of the students in a class. It's denoted the height of the student in a class, and it's follows some distribution. Let's take it's follows some distributions. It's maybe Gaussian, it's maybe non-Gaussians, it's maybe any distributions. Suppose let's take it's follows some distribution. And from these distributions we have collected some observations of this random variable. Suppose let's take we have collected the observations like that: x1, x2, x3. So let's take we have collected some 10 observations of this random variable, means height of the students. So these observations are called the random sampled from x of size 10. This thing. So here these things are called the random sample that we have collected from the distributions x, means this random variable x, and these collected sampled are called the observations. These are called the observations of the random variable x, and it's the random sample of x. It's called the random sample of x of size 10. So sample here n is equals to 10. That's the size of the random sample. Size of the random sample. Okay. So now the thing that I have to do, we have to estimate this is a simple sampled from these distributions, from this random variable. Now the work that we have to do, we have to estimate the population mean of the random variable x. The job that we have to do, we have to estimate the population mean of x. We have to estimate this population mean of the random variable x. Suppose let's take we have estimate it as mu. Okay, this is the estimation. Now the question is we can easily compute the mean of this random sample, but how? The question is how will compute the mean of the populations of this random variable? That's the question. How will doing this job? So now the questions that comes into the pictures, to get some better approximations, better estimations of these populations mean, the confidence intervals come into the picture. So now the answer that we got from here, the population means mu, the population means the mu will be approximate equals to our sampled mean. These things are actually called the sampled mean. These things are called actually the sample mean. And these things are called actually the population mean. And now the sample mean x bar, that we can easily compute the sample mean from this data, from this observed data. Since this can be now computed like that, 1 by n, I is equals to 1 to n sum over xi. So example here n is, in our example, here n is what? Here n is equals to 10. By using this sample, the question is how do we appropriately estimate this thing? So we can appropriately estimate these things if we increase the value of the n. Means here if I am taken the value of the 10, n is equals to 10. If we increase the value of the n, so this estimation will be is so much accurate of our population mean. So as n increases, that implies that our population means our sampled mean much better to our population mean. Means in limit, if you use the limit concept here, if you write these things as limit concept, limit as n tends to infinity, our sampled mean will be as tend to population mean. This thing, this concept is called the point estimation. If these limiting concept are actually called the point estimation concept. Means we have calculated the population mean by simply using the limiting concept from our observed point value. So these things are called the point estimation. Now the drawback of this point estimation is that, just see this concept, just see, if we increase the value that tends to infinity, means what? We have to collect so large amount of observed value. Sometimes this is not possible. These things are the actual main drawback of the point estimations. Okay, now let's try to understand this thing through an example. Just instead of taking the abstract data, if we just take a particular data of these examples, then I think this will be more clearer of us. Suppose let's take our random variable x. We have collected such kind of 10 observed value of this random variable x1, x2, like that, x10. We have collected this 10 value. Okay, now let's take suppose let's take these observed value are like that: 180 centimeter, 162 centimeter, 158 centimeter, 172 centimeter, 168, 150, 171, 183, 165, 176. Such like of 10 observed value we have collected from the random variable x. Means that's the height of the students. We have collected this. Okay, so this is the random sample. So the random, these are the height of the students in a height of students in a class that we have. Now the point estimation that tells us, the point estimation estimations of mu means population mean. If we find the population mean, this is the sample, random sample. This is the sample, random sample. So this is one of the random sample. Point estimations of mu means point estimations of the populations means of the random variable x. Now it will be what? How much point we have? Here n is equals to what? Here n is equals to 10. So these things will be 1 by 10 summed over I is equals to 1 to 10 and summed over all xi. If we just calculated all the value, then just before of this lecture, before of this making the video, I will calculated this value in my own calculator. So I got this value like that 168.5 centimeter. Just do your own calculations, then I think you will got this. Okay, so this is the point estimations of mu. These simple things are called the point estimation. Means it's not actually equal, it's approximate estimate. This is simple. Now now h a we have seen the h, if we increase the value of n, then the points estimations of our population mean will be more accurate. But the problem is that the large number the collections of the large number of random sampled value means collections of the large number of observed value is sometimes impossible. Means it is totally impossible to collect the large number of observed. So in such scenario, the confidence interval that we have to that's confident intervals that helps us estimate the right population. Okay, now let's see how these things are look like the confidence interval. Suppose let's take instead of using the point estimations, if I use this kind of informations to find the population mean. Suppose let's take, we will find interest to find the population mean and give some interval. Instead of using the single quantity, if we give some interval of it, means if we just tell you, if I tell you the population mean will lie on the 162.1 to 174.91. Okay, I tell you the population mean lie on this range, and also I give you some confidence of it with, suppose let's take 95% probability. With 95% probability. If we give means I am confident 95%. I am confident 95% that our population mean lie on that interval. These things are called the population mean. These things are called the population mean. These things called the interval that lie on a population mean interval. And these things are called the confidence. How much confidence we have to these estimations, to this means to this interval, on this interval, how much confidence means this is called the confidence. Okay, because if this kind of confidence, this kind of informations that we interest to find, these things are actually called the confidence interval. Means we have not estimate to a single value to our population mean, we give some interval of it. We have give some interval means we give the confidence that we have 95% confident that our population will lie on that interval. It could be lie anywhere on this range. It could be lie, suppose it could be like one, just I'm estimated it 162.1 to 174.91. It could be anywhere on this. It could be here, or it could be here, it could be here, anywhere between this range. It could be anywhere. And also I give the confidence, how much confidence I am that our population will lie on this range. Instead of considering a single value, I am considering this interval concept. Okay, I think this concept are much more richer. These concepts are much more richer concept than this. Okay, this is the main advantages of the confidence interval. Okay, because of this thing we will consider, we have to learn this thing, we have to learn and we have to use this consider interval concept for the estimation something. Okay, so because of that, for collections of the large amount of data is not always possible. So in such scenarios, to estimate something, instead of taking a single value for estimations, if we consider some interval with some confidence level, I think these type of informations are very useful to take a decisions instead of taking a single quantity. If we are taking the this kind of informations, if we taking this kind of information, that will give us more richer informations to take some decisions in a company. I think you will got the idea how the confidence interval are actually working and why these things are actually useful in real world. Okay, I think you got the idea. Now in next lecture we will see how to calculate this confidence interval value. We'll see this thing in next lecture.